The last of the circle theorems that we're going to talk about have to do with angles whose vertex is outside the circle. So we've talked about when the angle is equal to the arc, when the circle is the center of the circle is the vertex of the angle, the central angle equals the intercepted arc. We've got when the vertex is on the circle, and the angle is equal to half of the intercepted arc. We talked about what happens when the vertex is inside the circle. The angle is equal to half the sum of the intercepted arcs. And then lastly, we have what happens when the angle is outside the circle. And so if you look at this, we've got all of these cases. It's just they're secants and tangents, and what we have is that each of these, the vertex, if you look, the vertex for these angles 1, 2, and 3 are outside. Now it looks as though the angles are all, these equations are all different, but they actually all have something in common. If we look, we have this circle, and that angle is intercepted. If you imagine it like a laser beam that is cutting through a hula hoop, it's going to cut it into that yellow and purple. Same thing is going to happen with these. It's going to break them into these pieces, and those are our intercepted arcs. And so what we all have in common, though, is notice there are two, just like there were when the vertex was inside, but the angle is equal to half of the big arc minus the small arc. The angle is equal to half the big arc minus the small arc, and the angle is equal to half the big arc minus the small arc. So all of them have the same situation regardless of what it looks like. When the vertex is outside, angle X is equal to half of m minus n. This is what it looks like on the formula chart. So if we look at example 1, I have my angle. Remember, every angle has its arc or arcs that go with it. So once you find your angle, find your arcs. Then I have these two pieces. They're my arcs. And so I look, okay, the vertex is outside. That means the angle is equal to half of the arc, the difference between them. So the angle X is equal to half of the big arc, which was 170 degrees, minus the small arc, which is 72. So if I go in and do that math, be careful. Don't type in 170 minus 72 like this, divided by 2. Don't type that in on your calculator. Make sure you either use parentheses or you type in 170 minus 72, enter, divided by 2, enter. So be careful that you type it in correctly on your calculator and you get that X is 49 degrees. Now, the problem on example 2 is I need to subtract the arcs. So I have this angle here, and I need to subtract these two arcs that were intercepted, this 119, and then this little piece that I don't have. So the problem is I need to subtract them, but I don't have everything that I need. So I need to put that on hold. I need to go over here, and I need to add 174 and 119, and I get 293. So if I take, there are 3 pieces, so if I take the 293 from the 2 pieces and subtract it from 360, which is the whole circle, I find out that that arc, that little piece, is 67. Now, I'm not finished. I can't just divide that by 2. A lot of students think that because they subtracted, that now they just divide by 2. Okay, we're not looking to be able to subtract. We're looking, now we've got to come back and solve the problem. So now, angle 1 is equal to half of the difference between those two arcs. And so now that you know what the two arcs are, then you can come back and do the math. So 119 minus 67, and then divide that by 2, and you find out that that's 26. The same thing happens here. We have our angle for angle 1. We need to see which arcs we have. You need to learn to isolate those to make it easier for you to see which piece. I think that color works really well. So I need that green piece. Well, if I take 360 and subtract 138, I get 222 degrees. So that green piece is 222. Now you can use the equation. Angle 1 is equal to half the large arc minus the small arc. Half of 222 minus 138 is 42 degrees. And then the last one, you have 104, 111, 104. If you add those together, subtract those from 360, you'll find out that this little piece is 41. Now that you know the pieces, the vertex is outside, the angle is equal to half the difference. And so angle 1 is half of 111 minus 41. So 111 minus 41, and then divide that by 2, gives you 35 degrees. Now, so example 3, you're going to set up example 3. Don't worry about that. There's x's involved and algebra involved. The angle here is x. This arc DE is 2x minus 20, and this arc AC is 3x plus 17. And I think it's helpful to put things in parentheses because when you substitute into an equation, it is preferable, it's good practice for you to use parentheses because there's a mistake that you'll make if you don't do it. So we know that the vertex is outside, the angle is equal to half the difference. So the angle x is equal to half the difference. Now, because these are polynomials, I need to subtract them carefully. So I'm going to go ahead and put them in a bracket, and I'm going to take 3x plus 17, and then I'm going to subtract 2x plus 20. This is very important, and usually what students do is they'll do 3x plus 17 minus 2x minus 20. Well, the 2 gets subtracted, but the minus 20 doesn't get subtracted. So here is the issue with writing it like that. That's why it is better to substitute into parentheses because you're going to mess up that minus sign. So it's very important that you see that. So now we can go ahead and clean up. Let's distribute that minus sign so that it goes to everything. So we'll continue. X is equal to 1/2 times, and now we've got 3x plus 17 minus 2x. Oh, that should have been, that should have been a minus 20. I apologize for that. Originally it was minus. It's minus right there in the problem. Now minus a negative is plus 20. I got ahead of myself. Now I can put together combined like terms inside my parentheses. X is equal to 1/2, and then it would be x plus 37. See, if you didn't change that 20, then you would have -3 instead of plus 37. Now, instead of distributing that 1/2 to the x plus 37, multiply both sides by 2 to get rid of that so that you have 2x is equal to x plus 37, or x is equal to 37. And if I had asked for the arcs, you could have gone back in and substituted those. So the rest of these are just kind of a combination of all the different problems that we have done, but they're a little bit harder that you have to look at. So if we look at number 4, we see that this angle right here is 52. That also means this angle is 52. Well, notice where the vertex for the angle is. The vertex is inside. That means I need to be able to add the arcs. Well, the arcs that I have are 144 and x. Unfortunately, those arcs don't have an angle that goes with them, but I do know how to find it because I have linear pairs. So this angle is 128 because those two add together to be 180. Well, now I have, when the vertex is on the inside, not in the center, the angle is equal to half the sum. So the angle, which is 128, is equal to half the sum of the arcs. Well, the arcs are x and 144, so I'm going to add them together. Again, multiply by 2 all the way through, so you get 256 is equal to x plus 144, and solve, and you get that x is equal to 112. So x is equal to 112. Those are the two that you would average 144 and 112, and that would give you 128. So on number 5, again, notice where your angle is. Your angle's vertex is outside. That means you need 2 angles to subtract, or 2 arcs to subtract. So I have my y arc and my 30 arc. Well, the rule is that the angle is equal to half of the difference. So the big arc minus the little arc. Again, double the other side. That's the easiest way to get rid of that 1/2 instead of distributing, especially when you don't have even numbers. It's not the only way to do it, but it is the easiest way to do it. Add 30 to both sides, and you get that y is 82 degrees. Now, I'm going to go to 7 first, then we'll come back to 6 because 6 is a little tough. So 7, it just kind of depends on what you see first. If you look at this inside circle first, because of what we've been talking about, what you're going to find is that we don't have enough information to be able to do this problem because I don't have an angle and one of my arcs is missing also. So you've got to have 2 arcs and 1 angle. So you've got to have 2 of the 3 pieces to be able to find the missing one. So I don't have enough there, but what I do notice is that I have another circle. And usually in geometry, if you're given another piece of your given information, it's there for a reason. So now if I switch and I go to that outside piece, then I see that the vertex is on the circle. So if I ignore that middle circle and just use the 124, then the angle is equal to half the arc. Well, that means this angle right here, this little pink angle, that angle right there is half of 124, which is 62 degrees. Now I have enough to go in and use this inside angle because now this inside circle because now I have that angle. So now I know that the angle 62 is equal to 1/2 of the difference between the 2 arcs. So I can set it up. So again, multiply by 2 on both sides. You get 124 is equal to 167 minus x. Subtract 167 from both sides, and you get negative 43 is equal to negative x, or x is equal to 43. Okay, so now let's look at 6. There are a couple of ways that you can do 6, and I'm going to point them out. First, I think the easiest thing to start with is this angle right here. So if we look at that angle is x squared. That angle intercepts this arc. So I don't really know if you're looking at it and maybe you don't know where to start this problem. Then what I know is that the angle is equal to half the arc. So if that angle is x squared, then this arc is 2 times x squared because the angle is half the arc. So I'm going to go with that first. Then I notice, okay, I've got this other angle down here. Well, it doesn't intercept any part of the circle, but on the flip side, it is vertical. And that side of it intercepts the rest of the circle. Well, that angle is 236 minus 15x, and that angle is half of that arc. So if I double the arc, right, because if the angle is half the arc, then it is true then that 2 times the angle is the arc, right? So we can do this so we get that this is 472 minus 30x. Now here's what you want to see. From here, if you notice, that's the whole circle. The blue and the pink, that's the whole circle. Well, that's 360 degrees. So you can take 2x squared plus 472 minus 30x, and that equals 360. Well, since this is going to be a factoring problem because it's x squared, I'm going to subtract 360 from both sides, and I'm going to go ahead and rewrite it in an order that is beneficial to me. 2x squared minus 30x plus 112 is equal to 0. Notice that you have a greatest common factor of 2. So you can divide all the way through by 2, and that helps get down to something that's a little bit easier to factor. So you need factors that multiply together to give you 56, that add together to give you 15. So you're going to have x minus 7 and x minus 8. 8 and 7 multiply to give you 56, add together to give you negative 15. So set each term equal to 0. X minus 7 equals 0, which means x is 7. And x minus 8 equals to 0, which means x is 8. If I plug either of those in, they're going to work. And so I'm going to keep both answers. Now there's another way to do it. It is a little more complicated, but here's what happens. I notice that the pink angle intercepts that pink arc. And let me switch colors here and use something different. This angle right here, which is the linear pair to this 236, also intercepts that same arc. So we learned that 2 angles that intercept the same arc are the same size. Well, I need to know what that green angle is. So this angle right here, here's the tricky part. It's 180 minus, and you have to use parentheses, 236 minus 15x, which is negative 56 plus 15x. Well, those angles intercept the same size arc, so the angle x squared is equal to negative 56 plus 15x. And see, then you'll see we're right back here if I rearrange it and set it equal to 0. So there's two ways that you can look at that. Either you can use the whole circle in vertical angles, or you can use the intercepted, the angles that intercept the same arc are equal. And this last one is a challenge, and it's really, it's a challenge because it looks scary, but it's really not that bad. If you plug in these pieces, you plug in what you know that 2 is 89. I'm just going to get you started. Now look, you know 3, 7, and 8 already just because you know that. So don't forget linear pairs, vertical angles. Triangles add to 180. If CB is 23 and BN is 62, 64, 18, 63, and 57. Well, if you'll notice, there are only two pieces I don't know. I don't know that one, and I don't know ML, and I don't know JG. But I do know that they're one piece of a half circle that I don't have. So I can go in and find those other pieces. Then, for example, say I see 22. I see angle 22. Well, angle 22 right there intercepts this arc right here, which I just found that little piece, ML, and this other arc on this other side, 63. And so when the vertex is outside, you subtract. That'll give me 22. I could find 18 by doing the same thing. Here's angle 18. It intercepts this arc on this side, same arc you intercepted a minute ago, and this arc on the back side, the flip side of that. And so I would use both of those and add it together because the vertex is inside. Then that would give me 18. And so you can just continue. For instance, look at 12. If you look at angle 12 is a central angle, right? The vertex is at the center of the angle. And so the angle 12, if JG is 60, which we would have calculated, then 12 is 60. And so you can go through and you can find all of these angles using everything you know about circles, linear pairs, vertical angles, and that the angles of a triangle add up to 180. That applies here too. Anywhere you have triangles, that happens. So try this, see if you can do it.